Right, so this is chemistry, and in today's class, we're going to be discussing the concept of balancing redox equations, as you can see here. Now, I'm going to bring up a question, and then while solving, I'm going to be explaining in details, right? Let's assume we have a question. Okay. Now, this is the question we are given, and while solving this question, I'm going to try my best to explain in details. But first, you have to know that for this to be an equation, there have to be two sides. We have the left hand side and the right hand side. The left hand side is this, and the right hand side is this. So this left hand side, I believe we know this concept already. The left hand side is called the reactant. So everything on this left hand side, we call them the reactant, and everything on the right hand side, we call them the product. Right? So in balancing the redox equation, the first thing we have to do is to observe what is being reduced and what is being oxidized, right? Because from the word redox, it means reduction and oxidation. When we say reduction, it means reducing. When we say oxidation, it means increasing. Are you getting what I'm saying? So we need to know what is reducing and what is increasing. On the left side, we have Mn, we have O, and we have Fe. Understood, right? On the right hand side, we have Mn and we have Fe. Are you seeing that we don't have any O on the right hand side? I mean on the product side. So what do? Leave the O first. Don't bother yourself about the O. Let's look for what is reducing between the Mn and the Fe on the left and the right. So on the left hand side, I want to determine, the first step I want to know is to determine what is reducing and what is oxidizing. Determine the reducing agent and the oxidizing agent. So I will first start with Me. Remember I said ignore the O because we don't have any O on the right? So I will start with Mn on the left and Mn on the right. So I will look for what is the oxidation number of Mn on the left and what is the oxidation number of Mn on the right. So let's see that. So I'll start it with Mn. So I mean Mn on the left, it is together with O, right? And then there's a charge, there's a radical on it, and then I'm having a plus Fe. Sorry, let me write this properly so you can. So I'm having MnO4 minus plus Fe2 plus. So we have that's ion 2, and then it's giving us Mn2 plus Fe3 plus, right? So for Mn on the left, for MnO4 on the left, that's this one, I want to find the oxidation number of Mn here. So I'm having MnO4 minus, right? Since I'm looking for Mn, I'm going to make Mn the subject of relation. So this is going to be X plus 4 into the oxidation number of oxygen is a minus 2. So that's going to be equal to minus 1, right? Why is it minus 1? Because whenever they have a compound and then there's a charge, there's a radical on it here, the whole compound is going to be equal to what is on top. So assuming I have 2 minus here now, it means everything here is going to be equal to minus 2 here, right? But since I have just a minus there, I'm going to be having a minus 1, that's the negative 1. So simplifying this, I'm having X minus 8 equals minus 1, right? Taking it over, we have X equals minus 1 plus 8. That means X equals 7. So it means magnesium here is 7, magnesium here is 7, and magnesium here is 2. Are you seeing that? There's a 2 on top of here. Magnesium here is 7, magnesium here is 2. What do you notice? Magnesium is reducing. Here it was 7, but it came here and it reduced to 2. So this is reduction. That is reduction, right? And if you look at ion 2, Iron here is 2, but here it gained 1 electron, that is 3 here. So what can you say? It means iron here is being oxidized, right? Iron is being oxidized. I believe we understand the concept. All right, so having done that, what's the next thing I want to do here? Let's bring out the compound that is being reduced and the compound that is being oxidized. So for the compound that is being reduced, I want to start with the reduction, right? The compound that is being reduced here is this and this. So I'm having MnO4 minus, and on the right side I'm having Mn2 plus, Mn2 plus, right? This is the reduction, right? The compound that is being reduced, right? That's this one. So I'm taking that out, right? So when I'm done, I also do the oxidation. So starting with the reduction, what do I want to do here? If you notice closely, there is MnO. There is O on the left hand side. That is, there is an O here, but there's no O here, right? So in working with equations, we have to balance what is both on the left hand side and on the right hand side. What do I mean? Since there's an O on the left hand side, there will definitely be an O on the right. So how do I do that? I add oxygen atoms. How do I add oxygen atoms? I add water, right? I can't just add O, right? So I add water to this side. Now me adding water, I've introduced a new element, that's hydrogen, right? So how many oxygen atoms are here? We have only 1 oxygen atom, and here we have how many oxygen atoms? We have 4 oxygen atoms. So I can just put a 4 here, right, to give me 4 oxygen atoms, and then I have 8 hydrogen atoms here, right? So I can put hydrogen atoms here, that is hydrogen ions, on the left hand side. So this is leaving me with MnO4 minus plus 8 H pluses, right? Because I have 8 of it here. So I have ion, 8 molecules of hydrogen ion, and that's giving me Mn2 plus 4 H2O, right? Are you seeing now? So from here, what's the next thing I want to do? The next thing I want to do is balance the charges, right? Since I have Mn on the left, Mn on the right, O on the left, O on the right, H on the left, H on the right, let's balance the charges. How do I balance the charges here? The charge here is 1, right? The charge here is 8 times 1, that's 8. Here there's a 1 here, right, in the front of this M. That will be 1 times 1, 1. So here is 1, right, minus 1, sorry, 1 times minus 1 is minus 1, plus 8 times plus, Abby, 8 times 1 is 8, right? So when you do everything here, it should give you 7, right? That is the charges on this side. And on the other side, we're having 2 here. There's a 1 here, so 1 times 2 is 2, plus this side is a 4, right? And 4 times 0 here, there's nothing up here. 4 times 0 here is 0, so everything at this side is 0, right? We are balancing the charge. So I'm comparing the molecule here. I'm going to be multiplying the molecule and the charge. So since there's nothing on top of here, it should be 4 times 0, and that's 0. Here is 1. There's a 1 in front of here. So 1 times 2, that gives me this 2. Here is a 1, Abby, and 1 times a minus 1 here give me minus 1, and 8 times plus 1 is giving me 8. Now for the left hand side, I'm having 7. For the right hand side, I'm having 2. So now I'm going to reduce the left hand side. Why am I reducing the left hand side? Because it is the largest here. So I have to reduce this to 2, right? So the trick is this: when you want to balance your charges, right, you, after getting the number of charges on the left and the right hand side, the charge, the side with the biggest charge, you have to reduce it. So if this side is 7 now and here is 2, I have to reduce this bigger side to 2. If here is 8 and here is 10, I have to reduce this side to 8, so that both of them will have the same charges, right? How do I reduce the charges? I add electron. Now how do I reduce this to 2? The only way I can reduce 7 to 2 is to minus 5 from this. You agree with me, right? That means I'm going to add 5 electrons right? I'm going to add 5 electrons to this side. Are you getting what I'm saying? So as to reduce this 7 to 2, right? So I'm having MnO4, sorry, I'm having MnO4 minus plus 8H pluses. Then I'm adding 5 electrons. Are you seeing what I'm doing now? I added 5 electrons to that side so as to reduce it to 2, and then that's giving me on this side is the same thing I have here, Mn 2 pluses plus 4H2O, right? So I have 4 molecules of water. So if you look at this, let's check the charges again to see if the charges are balanced. So here we have 1 times minus 1 is minus 1, plus 8 times plus 1 is 8, then plus plus 5 times minus 1 should give me minus 5. So that will be plus times minus 5 giving me minus 5. So here should be a minus 5. That's everything on the left, right? And then everything on the right, I'm having here is 1 times 2, it giving me 2, plus 4 times 0 giving me 0, right? So minus 1 plus 8, minus 1 plus 8 is 7, right? And 7 minus 5 is 2, and here I'm having 2 plus 0 is 2. So the charges are balanced. Are you getting what I'm saying? So we are done with the reduction. Are you getting what I'm saying? Now let's go to the oxidation. For the oxidation, the compound or the element that's been oxidized is this one. It's iron. Here is iron 2. It increased to iron 3, so it's been oxidized. So I'm doing the oxidation now. I'm doing the oxidation, right? Stay tuned for the next video, please.